All right, ladies and gentlemen, welcome to an introductory lesson on the mole. If today has gone the way it should, you have already watched one Edpuzzle on an introduction to the mole by Tyler DeWitt, which is a great video. It does a great job of introducing the mole to you. And you also watched an introductory video on how big a mole is. If you watch those two, you should already understand the concept of counting by weight. It's something we do all the time at the hardware store, at the grocery store, where when you go up to the register, if you have a bag of apples, they don't count every single apple that's in the bag. They just simply weigh the bag of apples, and then they charge you an appropriate amount based on the weight. Since counting by weight was explained very well in those videos, I am not going to deliberate on that anymore. The second thing is what a convenient amount or a standard count is. And some examples from the videos that you watched prior to class would be that an egg is a dozen, a pair of socks 2, a ream of paper is 500, and we have a word like that in chemistry. It's called the mole. And the mole is an extremely large number, 6.02 times 10 to the 23rd. It's also known as Avogadro's number. So one of the things that's really super important in order to understand about the mole is that there is a relationship between the atomic mass unit and how many grams something is. And the number that's on the periodic table, if you were to go to ptable.com and look at the numbers that were there back in Unit 3, we learned things like, and you had to write it on your test, like if you had a boron atom, the mass was 10.81. However, when you wrote that down, it was important that you wrote a unit on the number. And 10.81 would have been atomic mass units. If you were to write down the mass of fluorine, it was 18.998, and the mass was atomic mass units. And so on and so forth for every number on the periodic table. But now that we're to the mole, there's another relationship that atom has. So one atom is 107.9 atomic mass units, but a whole mole of silver is 107.9 grams. So that number is kind of twofold on the periodic table. Not only does this represent the number for one atom of magnesium, but it's also 1 mole of magnesium. The only thing that we change when we go from an atom to a mole is an atom is in atomic mass units, and a mole we measure in grams. Probably the most important topic right there on that little picture out of everything that we do in this first unit related to the mole. Which means I'm already to the point where I'm able to summarize what we're learning today in this lesson. And these are conversion factors that you're going to need to know in order to do your homework for today. And conversion factor number 1 is something that you learned in Unit 3. That one atom of an element, doesn't matter what the element is the mass from the periodic table for that element in atomic mass unit. So one atom of vanadium is 50.942 atomic mass units. One atom of aluminum is 26.982 atomic mass units. Second very important conversion factor that you need to know about the mole is that 1 mole of any element is the mass from the periodic table for that element in grams. So if I were to look at beryllium, 1 mole of beryllium is 9.0122 grams of beryllium. 1 mole of helium is 4.0026 grams of helium. So I'm using the exact same number. The only difference between these two conversion factors is whether I put the unit of AMU or grams. And the last conversion factor that you should know from watching all of the videos prior to class is that 1 mole of anything is 6.022 times 10 to the 23rd anythings. Anythings, whatever it is. 1 mole of bunnies is 6.022 times 10 to the 23rd bunnies. 1 mole of pennies is 6.022 times 10 to the 23rd pennies. 1 mole of an element is 6.022 times 10 to the 23rd atoms of that element. So that brings me to your homework assignment. You do have a homework assignment to complete for class tomorrow. It's fairly straightforward. Those are the only 3 strike that. It's not 3 conversion factors. It's 237 conversion factors based on this periodic table, because there's 118 elements on this periodic table. And if I'm using this conversion factor right here, I just made 118 conversion factors. And if I am using this conversion factor right here, that's another 118 conversion factors. And then 1 mole of anything is always 6.022 times 10 to the 23rd. So that's a total of 237 conversion factors that you would need to know in order to do your homework for tonight. So let's take a look at what that homework looks like. You can find that homework by going to Schoology. Because this will be an important thing that you'd have to do. So you can go to Schoology and click on your chemistry class. And on that chemistry class, you will find in the February 16th folder, February 16th folder, we were supposed to review a test. Obviously that's not happening because you're at home and I'm here. There's a teacher presentation about the mole. That's what you are watching right now. And then finally, homework, an introduction to the mole. And if you click on that link for the homework is posted there. You can open it. And if you'd like to skip straight to the problems, you can do that. Here they are. Problem number 1 is just simply demonstrating that you understand how to do a conversion, just like what we did in Unit 1, and that you also understand the concept of counting by weight. So feel free to do number 1. You can just do this on a scratch piece of paper since you do not have this homework packet at home. Just take out a piece of paper, write 1A, go ahead and calculate what 1A is. Do 1B, calculate what 1B is. If you get really hung up on number 1, save it. We'll go over it in class. It'll be fine. Same thing's true for number 2. Sometimes number 1 and number 2 really confuse students, and if you're hung up on those, just save it. We'll go over it when you get to class. 3 and 4 should be questions that you can answer based on the videos that you watched prior to class. And question 3, from your knowledge from first semester, when we talked about atomic mass units in Unit 3. Which brings me to question 5. In question 5, there are 4 problems for you to do, and I duplicated a problem just like that in my notes right here. So this problem right here is very similar to question 5. It says calculate the mass in AMUs of aluminum that has 75 atoms. So question 5 says calculate the mass in AMU for each of the following. So if I do the sample problem in the notes, you should be able to do question 5 no problem. First thing I did was I made a conversion grid just like what we learned in Unit 1. And right here I did write what was given to me from the problem. 75 atoms of aluminum. Now the question is, what am I trying to get to? I'm trying to get to atomic mass units. So how do I convert from atoms to atomic mass units? 1 atom of element X equals the mass from the periodic table in AMUs. So if I'm trying to find 75 atoms of aluminum, I need to go to the periodic table, find aluminum, and it is 26.982. 26.982. So there is 1 atom of aluminum is 26.982 AMUs of aluminum. The reason I would put atoms on the bottom is so that the atoms cancel out. And when those atoms cancel out, the only thing that I'm left with from this problem would be AMUs of aluminum. And my final answer, if I do multiply those across, because that's how you'd solve this problem, take 75 times 26.982 and divide by 1. This is what you get. In theory, 75 has 2 significant digits, so you should round this to 2 significant digits, which would be 2,000. Atomic mass units of aluminum. I do know that different chemistry teachers talk about 75 as a count, and you might treat this number slightly different, so I would recommend doing what your chemistry teacher tells you to do in their class on how they handle an actual count. So that's problem number 1. And to do problem number 1, I did use this first conversion factor that says an atom of an element is the mass from the periodic table in AMUs. Problem number 2 in my notes is just like number 6 on your homework. So just like number 6. So this sample problem would help you do question 6 when you're going through and doing it. And in this case, I'm given something in AMUs. It says calculate the number of sodium atoms. So this is how many AMUs of sodium I have. So this is the same exact problem. It's just that I'm using the conversion factor in the reverse method. If I start with AMU and I want to know atoms, I would just simply take the AMU from the periodic table and write it down there. And then atoms would be on the top. And the reason that I would write AMUs in the bottom is so that the AMUs of sodium would cancel the AMUs of sodium, and what I'd be left with would be atoms of sodium. Where did I find that conversion factor? I went to my handy dandy periodic table. 22.99 is 1 atom of sodium in atomic mass units. If I take this number times 1 divided by 22.99, I do get 51 atoms of sodium. And just like I said before, how your teacher actually handles a count, a number that's a count, would be up to that individual teacher because it can get tricky. 51 atoms of sodium is what I would accept because I think a count has an infinite number of significant digits. But that is a topic for your own individual chemistry teacher and what they want you to do with that. Moving forward then, after problem number 6 would be a problem like number 8. There is a problem number 7 in your homework where you can give that your best shot, see how you do with that. But problem number 8 on your homework says that if you use the average atomic mass from the periodic table, calculate the number of moles for whatever is listed below. So how many moles would you have if you have this? So this is given in grams, which means I'm no longer using this first conversion factor, so I'm going to scoot that one off to the side. I'm now using this one. If I'm given a mass in grams, can I find moles? Oh, sure. It's just like the other problems that I was doing. So I'm going to write down what I was given in the problem, and that is 85.32 grams of zinc. I'm going to go to my handy dandy periodic table and look up zinc. 65.38 grams is 1 mole. So notice I'm using the word grams now instead of atomic mass units. 65.38 grams, 65.38 grams is 1 mole. So that same number in the periodic table is used sometimes as AMUs, sometimes as grams. That can be confusing when you're first learning it. To solve this problem, I take 85.32 times 1 divided by 65.38, and when I do that, I get that number right there. Now in this case, I did start this problem with 4 significant digits. So no matter what, you should round this answer to 1.305 moles of zinc. There is no other significant digits that you should use. 1.305, I would need to round up to 5 because this number after it is a 4. The reason I put these conversion factors in the way I did is so that the grams would cancel out, which leaves me with moles, and that's what my final unit is. The last problem that I'm going to review in these notes would be, what if we do the exact opposite of the one I just did? You're given moles, and you're supposed to calculate mass. This problem is exactly like number 9 in your homework, so when you're doing problem number 9, you might want to look at this as an example. You could even write these examples down. Feel free to do that. But if you have 5.43 moles of zinc, that's what you're going to start the problem with. So if moles are here, I have to have moles down there, and I know that the conversion factor involves 1 mole, because the conversion factor in the notes says if you have 1 mole of element X, it's going to be that element in grams. Same number I had before, 65.38. 65.38. So 1 mole of zinc is 65.38. It's the exact opposite of what I did before. The reason I wrote moles on the bottom for this one is to show you that moles will cancel. Why am I making such a big deal about canceling out the units? because this is one of those things that we go through this unit, and time after time after time, people write these conversion factors, these numbers, in the wrong place. They'll put this one down here and this one up here, and it's always about the units. You want to make sure that you end up with the unit that you're trying to find. When this problem is all said and done, I took 5.43 times 65.38. I got this number on my calculator. However, when I started, I had 3 significant digits. So when I finish, I should have 355 grams of zinc. And that's the only answer that you should have. So at this point, you could go on Schoology. And when you are on Schoology, you can find that homework assignment related to the mole. The example problems that I just did for you were just like number 5, 6, 8, and 9. So I did give you an example problem for most of the homework assignment that's there. I will say for everything else that's there, you do have the background information that you need to solve those problems. 10 is putting a couple of those conversion factors together to try to work some of those out. Some of them are very straightforward, but you can do it at this point. So take the remaining time that you have dedicated for this class and solve these 10, which is really like, I don't know, 20 homework problems or so. Just do it on a piece of paper and be ready to show that piece of paper to your teacher the next time that you have class with them. And this video will count for the attendance for today since it's being recorded on Edpuzzle if you watched it. Thanks, bye.